Alright, so this is our second video on conditional probability. We're going to take a look at this from a more formal point of view. And we're actually going to provide a formula for conditional probability. So we're going to say that the probability of some event B, given that we know some event A is happening or has happened, is equivalent to the probability of both events occurring over the probability that the antecedent, the event that we believe has already happened. Okay, so this is like somewhat not intuitive, and I believe that the best way to kind of parse this out is to kind of look at it from the point of view of a two-way table. So we're going to create a two-way table. And what we're going to do is we're going to make this like a positive test for drugs versus a negative test result for drugs. So this is the testing results. As opposed to someone who uses drugs as opposed to does not use. So this is the observed, right? This is what people actually do. They either use drugs or they do not. So we're going to give ourselves a subset population size of 555 people. And we're going to break them into these categories. We're going to have 45 land here, 5 land here. So our, the total number of drug users out of 555 should be relatively small, which we've got 50 out of 555, which is a small number. The non-users is going to be much larger, and we've got 25 here and 480 here. Now note, this one and this one is when the test gets it right? Positive result when you use drugs, negative result when they're not using drugs. So these are the true positive, the true negative. These are when the test gets it wrong. This is the false negative, this is the false positive. Right, so we would expect if it's an effective test that these numbers are larger than these ones, which they are. Okay, so let's establish some. So I'm going to kind of hold this off here. Let's establish some events. Let's make P being having a positive test. And let's make D uses drugs. So these are going to be my two events. And let's say I want to calculate two things. I want to calculate the probability that I get a positive test if I'm testing a drug user. And I want to know the probability that someone is a drug user given that they had a positive test. This is probably the more important one. The probability that they actually did use drugs if they tested positive. Okay, so let's kind of work this out in an intuitive sense, right? In an intuitive sense, well, I want to know how many drug users were there. Well, the number of drug users is 45 plus 5. That's 50 drug users, right? So out of the drug users of 50, right, we would say that 45 of them got a positive result. So the expectation here would be 45 out of 50, which lands me at this 0.9. So 90% of the time that we give the test to someone who has used drugs, it comes up positive. It's pretty good. All right. So let's try this the other way. So this is the number of people who had a positive test. So positive test takers, so it's going to be 45 and 25. That's 70. Right. So out of those 70 people, right, how many of them were actually drug users? Well, there would be 45 of them. So out of the 70 who came up positive, 45 were drug users. That means that we have a 0.643. That's not as good, right? So this means that 64.3% of the people who got a positive test were actually drug users. I think that's enough to question whether or not this is a good enough test. So realizing these are not the same, right? But you'll note I did not use this formula to get those answers. But you could use this formula, okay? So I'm going to clear a bunch of this out. I'm going to make myself some space here. Let's get rid of that. Get rid of all of this, right? Get rid of all of this. So we're going to remember that 0.9 and the 0.643. Those were the answers that I came up with, right? 0.9 and 0.643. Okay. So if I'm looking at my rule here, the probability of P given D, right? So that was the first one I calculated, should be the probability of P and D over the probability of D. Right? So this one's a P. P and D over the probability of D. Okay, so the probability of being both is the 45 out of 555. 555. Okay. The probability of just being a drug user, well, there was 50 drug users in the group, so that's going to be over 50 out of 555. And we know from a little bit of arithmetic that to divide is to multiply 555. I don't know why that keeps making that 550. Let's make that 555 in the whole population. Right, so to divide is to multiply by the reciprocal, and lo and behold, haha, these cancel, giving me the 45 out of 50, which is that 0.9, which I expected from my intuitive way. So the formula here gives me the exact same result, because when I take it from the general population in both cases, the general population cancels out, leaves me with 45 out of 50. Huzzah. Okay, great. So let's see if it works with the D given P, and does that give me that 64.3 again? So let's clear some space here, do some erasing. Oops, I didn't want to get rid of the uses there. That's the people who use drugs. That's still part of the table. All right. So clearing this all out. Erasing, erasing, erasing. So we want to take the inverse of that, right? Which is really probably the number that we actually want to know if we want to know if this test is effective. So let's find the probability of D given P. So given that they had a positive test, what is the probability that they did drugs? So that's the probability of D and P, right, divided by the probability of P. Well, D and P is the same as the probability of P and D, right? So that's still the 45 out of 555. 45 out of 555. Okay, great. The probability of P, its probability of positive test is going to be 70 out of 555. All right, and the same game happens, right? To divide is to multiply by the reciprocal. Again, the 555, the population size, cancels out, gives me 45 out of 70, which gives me that 0.643, 64.3% that I expected. All right, so what have we shown here? We've shown that the intuition of conditional probability can actually be encapsulated into a formula that you can use for calculations, and you can manipulate. And we'll do some manipulation with that later on in classes. All right, so there you go. That's your second notes on conditional probability.